Right, as we continue studying in triangles, today we're going to talk about proving triangles are similar. In the past, we've talked about proving triangles congruent. What's different between similarity and congruence is the length of the sides. So in both congruence and similarity, angles are going to be the same. However, in similarity, sides are going to be proportional, which means their ratios between the sides are going to be the same. And we'll demonstrate that in some examples shortly. So the first way to prove triangles are similar is through angle-angle. If you have two congruent angles in a triangle, and in a second triangle, if you have two congruent angles that match the first, the triangles are going to be similar. Now the triangles can be different sizes, which is why this isn't used for congruence, only similarity. Here's an example of a problem where we can use angle-angle. So in this case, angle R and angle V are given. And so as we go through proving angles are congruent because they're given, angles are congruent because they're vertical, and occasionally angles are congruent because they're alternate interior when we have parallel lines. Okay, so those are the three most common ways that we find angles are congruent. In this case, we have our given, and then these are going to be vertical. And so now we have, in this problem, two congruent angles, and that gives us angle-angle. So again, our explanation is this angle here, using three letters, is congruent because they're vertical. Angle R and angle V are congruent because they're given. And if we have two angles and two triangles that are congruent, then they're similar by angle-angle. All right, here's another problem that we can use angle-angle for. In this case, this right here tells us that the angles are perpendicular. So right here, we have two 90-degree angles. So this tells us that these two angles are congruent. These two 58s are given. So in this case, these two triangles are congruent by angle-angle. If I named it by AXM, A is going to match up with B. They both have 58 degrees. X is going to match up with X because they both have 90 degrees. And then M and K are going to match up because 90 plus 58 subtracted from 180 would give you angles M and K, which are both congruent. So the other triangle would be labeled BXK. All right, there's two other ways to prove triangles are similar. So we have angle-angle, we have side-angle-side, and we have side-side-side. So just a few minutes ago, I talked about how in similarity, sides are proportional. And so when you look up these definitions here, you're gonna see that sides are proportional. The angles are going to be congruent still. So in this case, we have angles that are congruent, but this side would be proportional to this side. Not congruent, but proportional. So we can't use congruency marks. We have to prove them proportional using a fraction, a ratio, a similarity ratio. So we're gonna look at some examples for both of these next. All right, so in this first example, we have three sides given. Now in this problem, we have two different lengths of sides. So I will say, how do you know which one to match up to what side? So in this case, look at the left triangle. What is the small side? And the small side is 6. If we look at the right triangle, what is the small side? The small side is 8. So those are going to be in similarity ratio together. If we look at 9, 9 would be the bigger of the two sides. And over here, 12 would be the bigger of the two sides. So that would be our similarity ratio. So we have 6 over 8 and 9 over 12. And if those two are congruent to each other in ratio, then the sides are similar. And if we look at our calculations here, right, we find out that 6 over 8 equals 0.75 as a decimal, 9 over 12 equals 0.75. So since these decimals are the same, these sides are proportional. And since the sides are proportional, this would be similar by side, side, side. Okay, so and the theorem says that the three sides have to be proportional, and here's how we proved sides are proportional. All right, here's an example for side-angle side. All right, so we look here, the biggest side in the left triangle is 18, the biggest side on the right triangle is 36. So because they're both the largest sides, we're gonna use those, and we get 0.5. Here we see 12 is the smaller of the side is gonna go with 24. That's also 0.5. Since the decimals are the same, the sides are similar. Okay, since the decimals are the same, the sides are similar. And then however you write it, we just have to make sure the parts match. So I went ZVY. Z is the side, the angle of the long side on the left. So the angle on the long side on the right would be x. And so that's how those match up. All right, now we're gonna find missing lengths. In those problems, the lengths were given. We just had to prove which of those angle, angle, side, 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 or side, angle, side were used. So in this case, we're gonna solve for a missing length. And so in this case here, we have two sides and two sides, but we don't really know which side is big and small for the x. So the missing value here, we don't know. So in this case, if we look at 6, it's between the two sides that have angle markings. So and if we look over here, x is between the two sides with angle markings. So we can use what's given in the picture, in the problem, to help us determine what goes with what. So in this case, 6 is going to be on the left side, 6, and then on the right side we go with x. On the left side would be 8, and on the right side is 12. So one way to set up your fraction would be the left shape numbers and then the right shape numbers, as long as they match. So 6 will partner with x, 8 will partner with 12. And then the steps we use in this is cross multiply and divide. So we're going to cross multiply 8x and 6 times 12, and then divide by 8 and get 9 for our answer for x. So this side right here would be 9. Now using this methodology, we can determine real world problems to find, say, heights of objects that we physically can't measure using a comparison. So one way we could do it is a shadow method, and this is called indirect measurement, where we're actually measuring the height of something without physically with a ruler or measurement device measuring the height. So if you have a person who's 6 foot tall at a given time, on a sunny day, they have a shadow, say, of 4 feet. Whatever object you're trying to measure, so in this problem, a cactus, it's pretty tall. Some cactuses can get quite tall. So we want to figure out how tall it is. So we measure this, which is pretty easy to do, and we find out that's 9 feet. So 6 is going to go with x, because they're both the vertical dimension of the shape. 4 and 9 are the shadows, so those are going to go together. So 6 will partner with x, 4 is going to go with 9. So we cross multiply and divide, and we get that the cactus height is 13.5. And that would make sense because, you know, if we needed to measure 13.5 feet, we would need a pretty tall ladder to do that. So just kind of summarizing this, to prove triangles are similar, we have 3 ways: angle, angle, side, 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 angle, side. We have to prove sides are congruent by proving to prove sides are similar, we have to prove they're proportional, and we do that by comparing their fraction equivalents. So all of the sides in a given triangle have to be proportional. All sides have to have the same decimal in order to be proportional. And if you have all proportional sides in your triangle, then you can prove triangles are going to be similar by side, 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 or side, angle, side.